Let's solve Unit 9 Data Communication and Computer Networks questions. In a stop and wait system, the bandwidth of the line is 1 megabits per second and 1 bit takes 30 milliseconds to make a round trip. The bandwidth delay product is. Before getting on to the calculation, let's first understand the context of this question. In stop and wait system, the sender transmits one frame and waits for an acknowledgement before sending the next. So what is bandwidth here? The rate at which data can be transmitted. That is given as 1 megabits per second. And what about the round trip time? The time it takes for a signal to go to the receiver and then back. So this is 30 milliseconds that is taken from the question. So this round trip time and bandwidth parameters are a part of stop and wait system. In that they have asked about bandwidth delay product. What is it? It is the amount of data in bits that can be in flight on the network. It means the transmitted bits but they are not yet acknowledged. Only when you get an acknowledgement it will be sending the next one. That is stop and wait for an acknowledgement. But here it is transmitted but not yet acknowledged means those bits are in flight. It means it is in movement. It has left the sender but still we don't know whether it reached the receiver or not because the sender has not received any acknowledgement. This is the bandwidth delay product. It is the amount of data that has to be mentioned in bits. That's why the answer is given in bits unit in all the 4 options. Bandwidth delay product can be calculated by multiplying the bandwidth value into round trip time. The given values are bandwidth and round trip time. 1 megabits per second. Since we want the answer in bits, megabits have to be converted to bits first. We know 10 to the power 3 will be 1 kb, then 10 to the power 6 will be 1 MB. 1 Mbps is 1 into 10 to the power 6 bits per second. What about the round trip time? They have given 30 milliseconds. 30 milliseconds can be written as 30 into 10 to the power minus 3 seconds. Now we have to find the bandwidth delay product. What is 10 to the power 6 into 10 to the power minus 3? This will be 10 to the power 6 minus 3 which is equal to 10 to the power 3. So this is what we get here. 1 into 30 will be multiplied and 30 will be retained here. So what is 30 into 10 to the power 3? 10 to the power 3 is nothing but 1000. So 30 into 1000 will give you 30,000 bits. So overall 30,000 bits will be the amount of data that can be in flight on the network. Option number 3, 30,000 bits will be the right answer. Let's take this bandwidth unit now. Bandwidth unit will be bits per second. And what about RTT's unit? It is seconds. So this second and this second will get cancelled and only bits will be retained. Always practice such questions along with the units, only then you will have clarity. If the answer is not stressing any unit, we may just go with the calculation as it is. But since the answer is stressing in bits, we have to make sure the final value should be in bits. Next question, they have given hexadecimal digits. CB84000D001C001C is the content of a UDP header in hexadecimal format. The source port number is. If you would have watched previous year question solution videos, you could have got an idea about IPv4 header. The user datagram packet format is this one. They are talking about UDP header. So we are getting into this particular diagram. This is the header format. We have source port number, destination port number, total length and checksum. When you take into bits, it is 8 into 8, 64 totally. Each hexadecimal digit represents 4 bits. It means 4 plus 4 plus 4 plus 4 will give a total value of 16. It means how many hexadecimal digits are involved to get the source port number? 4 hexadecimal digits are involved from this particular content. The source port number is the first 4 hexadecimal digits, which is CB84 to the base 16, because this is mentioned in hexadecimal format. In hexadecimal representation, 0 to 9 will be as it is. For 10 we have A, 11 we have B, 12 we have C, 13 we have D, 14 we have E, and 15 we have F. So here C means it is 12 and B means it is 11. How will we convert this particular hexadecimal to decimal? We have to use 16 power. Say for example, you have to start from 16 power 0, then followed by 16 power 1, then 16 power 2, then 16 power 3. It goes on this way. First we will have 16 power 0, 16 power 1, 16 power 2 and 16 power 3. We will place 4 here, the next digit 8 here, then B here, then C here. Instead of C we will have 12, instead of B we will have 11. 8 into 16 power 1 will be 8 into 16, 4 into 16 power 0 will be 4 into 1. What about 16 power 3? That will give a value of 4096. 16 power 2 will be 256. 12 into 4096 will give a value of 49152. 11 into 256 will give 2816. 16 into 8 will give 128. 4 into 1 will give you 4. If you add all these 4 numbers, you will ultimately get 52,100. It is available in option number 1. So option 1 will be the right answer. Every hexadecimal digit will represent 4 bits, and whatever is given here 0, 16, 31 will be in the form of bits only. So if you have 4 bits for one hexadecimal digit, 4 hexadecimal digit will make up to 16 bits. Next question. The packet sent by a node to the source to inform it of congestion is called. Congestion control refers to techniques and mechanisms that can either prevent congestion before it happens or remove congestion after it has happened. So we are dividing this into 2 categories. Open loop techniques come under prevention and closed loop techniques come under removal. In open loop congestion control, we have the following policies: retransmission policy, window policy, acknowledgement policy, discarding policy, admission policy. This option belongs to open loop congestion control. And when you take open loop, it is about prevention. Here they say the packet sent by a node to the source to inform it of congestion means congestion has happened. When there is some preventive policy, the congestion should not happen. If that is the case, then there is no need to inform it to the source. So from this itself we can rule out option number 4. Next we will see closed loop congestion control. Under this we have back pressure, choke packet, implicit signaling and explicit signaling. Now let's see about the option. What is this explicit signaling? The node that experiences congestion can explicitly send a signal to the source or destination. Here there is a choice between source or destination, but the question is clearly stating it will be to the source. So definitely it is not explicit signaling. What about back pressure? A congested node stops receiving data from the immediate upstream node or nodes. If this is going to be the node that is congested, it will stop receiving data. What will happen? It will immediately create some back pressure where this node will be informing this node will inform this node, and finally this node will inform the source. Is it directly communicating to the source? No. So back pressure will not directly communicate to the source, which is asked in the question. So it is not back pressure also. What about choke packet? Choke packet is a packet sent by a node to the source to inform it of congestion. This is the exact statement that is asked in the question. Option number 3, choke packet will be the right answer. Here this is the congested node. This node is directly sending a packet to the source without involving other nodes in between as that of back pressure. So this is to give you the difference between choke packet and back pressure so that it will be helpful for you in some other question paper. What about this retransmission policy? We will see only about this because it is given in the option. If the sender feels that a sent packet is lost or corrupted, the packet needs to be retransmitted. Retransmitting the packet thinking that it is lost or corrupted. So regarding the other policies that is present here, implicit signaling, window, acknowledgement, discarding, admission, you can go through the reference book and understand them. For this video, I have just stopped with the options. Next question, which of the following is not the characteristics of packet switching? We have two kinds of switching, packet switching and circuit switching. First, we will get into packet switching. This is the method to transmit data efficiently and flexibly. Data is divided into packets. Packets can travel independently. It can take its own route. Since it can take any route, there is no dedicated path. Since every packet is going to travel a different route, it is decided based on the router from where it has to travel. It means we have dynamic routing, no static routing. So this dynamic routing is also a characteristic, and because of this there will be efficient bandwidth usage. If the data packet is going to be of very small size, the remaining bandwidth will be wasted. Instead, when the data is divided into packets, all packets can travel in the same time, which will lead to efficient bandwidth usage. Now let's get into the option. Data is broken into packets. Yes, it is true. Each packet may take a different route. Yes, it is true. These 2 points are referred. It requires a dedicated path. No, it does not require. It supports dynamic routing is taken from this point. This is also true. So which is not the characteristic? Option number 3 requires a dedicated path will be the right answer, but it is not the characteristic of packet switching. Now which switching has dedicated path here? It is circuit switching. It's a method of communication where a dedicated physical path is established between the sender and receiver for the entire duration of the conversation. So there will be 3 stages. First, it will be setting up the circuit. The route will be set up, the data will be transferred, and after the data transfer is over, the circuit will be toned down. That's what is given as circuit establishment, the setup phase, data transfer phase, and circuit disconnect phase. That is the tear down phase. So from this question, you can take idea about both packet switching as well as circuit switching. Circuit switching might help you in some other question paper. Next question, arrange the steps involved when a user enters a URL in a browser and accesses a website. Imagine you are just going to a browser and you are typing www.somewebsite.com. What happens before you see the website's homepage? That's what they ask you. First, the URL will be entered in the browser. So C will happen first. The user types a web address into the browser. Next, you will enter www.example.com. This is the URL. But internally, what is this actually? It's an IP address. So what will happen next is DNS resolution will take place. The browser asks the DNS server to resolve the domain name into an IP address. Every website will be mapped to an IP address. So DNS resolution will be the next step, which is A. It will ask the DNS server for IP address and the IP address is obtained now. The DNS server responds with the IP address of the web server hosting the site. We have got the IP address now, which is D. After that, HTTP request sent will be B here. The browser sends HTTP or HTTPS. This is secured request to the server at that IP address asking for the web page, and once the request is sent, the web page gets displayed, which is E. The server responds with the requested content, which will contain HTML, CSS, JavaScript, some kinds of images, everything, and the browser renders the web page for the user. What is rendering? It is actually using all these technology. It is actually displaying the web page to the user. It is not displaying just text. It is displaying the text in the given format along with the styling option, along with some scripting and images or any other videos that it has. So the process of doing everything together and presenting it to the user is what we call as rendering the web page. What is the order here? CADBE. Option number 4 will be the right answer. Next question. Arrange the process of virtualization in cloud environments. Forget about cloud environments. Just take your own system. Say for example, you are running Windows OS in your system. Most of us will run the same OS. Only few of us have tried Linux. In this Windows system, you will install something called hypervisor. If you want, you can take examples like VMware. After installing the hypervisor, you will have an image of the operating system that you want to run on Windows. Say for example, I have my Ubuntu OS. So after installing the hypervisor, what we will do is we will create virtual machines for this Ubuntu OS. Once you create a virtual machine, the machine will be allocated some RAM, some storage, everything will be allocated to the OS that is running on the hypervisor. So after the resources are allocated to this particular OS, the virtual machine will run separately. So this is happening in a single system. In cloud environments, the same process will happen. So let's start with the first step. Hypervisor is installed on the physical server. Why they are talking about the server here? Because we are in cloud environment. We are installing the hypervisor in one of the servers and not in our local machine. So hypervisor step is step A. The hypervisor like VMware, Hyper-V or KVM is installed to manage and create virtual machine. After that, the virtual machines are created. This is step B. The hypervisor creates multiple virtual machines, each acting like a separate computer. After the virtual machines are created, resources are allocated to virtual machines. When you create, you will be specifying all the resources. Internally, all these things will be assigned to each virtual machine. So this is step C. CPU, memory, storage, network resources are assigned to each virtual machine based on the requirements. After resources are allocated, virtual machines run isolated workloads. This is D. Each virtual machine operates independently, running its own operating system and application securely and in isolation. One virtual machine does not depend on the other virtual machine. So the order will be A, B, C, D, which is available in option number 2. Next question. Which of the following are controlled access protocols? We have already seen about controlled access protocols in one of the question paper, which was about multiple access protocols. So let's see the multiple access protocols. It has 3 divisions: random access protocols, controlled access protocols and channelization protocols. Aloha CSMA, CSMA CD, CSMA CA. Carrier sense multiple access is CSMA, CD is collision detection and CA is collision avoidance. In channelization, we have FDMA, TDMA, CDMA, frequency division, multiple access, time division and code division. What about the control access protocols? We have reservation, polling and token passing. Reservation, polling, token passing. TDMA belongs to channelization, CSMA CA belongs to random access. Option number 2, A, B and D only will be the right answer. Next question. Which of the following are examples of data encoding schemes? When it is about encoding schemes, we have come across A, B and E. If you would have practiced previous year question papers, definitely this question wouldn't have taken much time for you. Line coding is the process of converting digital data to digital signals. Data in the form of text, numbers, images, audio, video are stored in computer memory as sequence of bits. Line coding converts a sequence of bits to digital signal. What is actually happening? Data encoding is happening. That's what they have asked in the question. We have these many categories here: unipolar, polar, bipolar, multi-level and multi-transition. Under unipolar we have NRZ and polar also we have NRZ and biphase, and here we have Manchester and differential Manchester encoding, and then bipolar AMI is specified as it is. So option A, B and E are right. Option number 4 will be the right answer. In 2 or 3 previous year question papers we had questions regarding these schemes, so it's better you take an idea about it. Next question. Which of the following statements are true about encryption techniques? They have given about symmetric key cryptography, DES technique, two-fish symmetric block algorithm and RC4 stream cipher. So let's see one by one. In symmetric cryptography, the same key is used for both encryption and decryption. The key itself must be kept secret, but the functions are typically public. In the sense, the algorithms are public. Security relies on the secrecy of the key, not the key generation function. Let's see statement A. In symmetric key cryptography, the secrecy or protection of the key generating function must be of higher level than the decrypting function. Since the same key is used for encryption and decryption, you cannot say it is of higher level than decrypting function and all. So this statement is definitely wrong. Let's see about DES technique. The statement says the technique works by taking 64-bit chunk value and 56-bit key over a series of transformations. So let's see data encryption standard. DES operates on 64-bit blocks of data using a 56-bit key plus 8 parity bits that are not used in encryption. It performs 16 rounds of transformation on the data. This statement is perfectly right. What about two-fish symmetric block algorithm statement? It works on variable key length of up to 196 bits over a block of 128 bits. Let's check the statement. Two-fish operates on 128-bit blocks. This is right and supports key length of 128, 192 or 256 bits. They have given up to 196. But 192 is supported as well as 256 is also supported. So let's have a check here. What about D? RC4 is the most commonly used stream cipher that encrypts and decrypts a stream of bits or bytes instead of blocks. RC4 is a widely known stream cipher that processes data byte by byte. This is what is given as stream of bits or bytes. This is fine. It was used in protocols like SSL, TLS and WEP, though it's now considered insecure for many applications. We are not worried about whether it is used today or not. So definitely D is also right. As per the official answer key, they have marked option number 4 to be the right answer. But this part of the statement is right while this is not. So they have given C also as right. Taking this into account, we are marking C to be partially correct, but this is under question mark because the key length supported will be 128, 192 or 256. So variable key length is also right, but the value mentioned here is not right. So taking into consideration, we can mark B and D to be definitely true. A is definitely wrong, but C is partially right and partially wrong. Next question, match list 1 with list 2. So let's start with count to infinity problem. This is a classic routing problem in distance vector protocols. So distance vector routing algorithm will have this problem. A will be mapping to 2. A2 is actually available in 3 of the options. Routers continuously increase the cost to reach an unreachable destination due to outdated or incorrect information, causing a routing loop that delays network convergence. Sometimes the destination might be unreachable because of incorrect information or outdated information. So without that information, the routers will be trying to increase the cost to reach that particular destination. This is actually count to infinity. Infinity in the sense that is unreachable destination. Next we'll get into IEEE 802.16 and 802.15. IEEE 802.16 is the standard for WiMAX, which provides broadband wireless access over long distances. B will be mapping to 3. It is also available in 3 of the options. What about IEEE 802.15? This defines the standards for wireless personal area networks, including Bluetooth. C will be mapping to 4. C is mapping to 4 only in one of the option. Option number 2, A2, B3, C4, D1 will be the right answer. What about AODV protocol? Ad hoc on-demand distance vector is a routing protocol. specifically designed for mobile ad hoc networks called as manets. D will be mapping to 1 as specified in this option. Next question, match list 1 with list 2. So this is from network security, digital signature, hash function, AES and RSA. So let's start with digital signature. Digital signatures use cryptographic techniques to verify the sender and ensure that data has not been altered. Verifying the sender is called as authenticity, and ensuring that the data has not been modified is integrity. A will be mapping to 2. A2 is available in 2 options. What about hash function? Hash functions like SHA-256 take input of any size and produce a fixed length output used for integrity checks. Here the input can be of any size, but the output is of fixed length. This can be equated to produces a fixed size digest. Whenever you have output in such cases, it will be called as digest only. So B will be mapping to 3. B3 is also available in 2 options. What about AES and RSA? AES, Advanced Encryption Standard, uses the same key for both encryption and decryption. When we use same key, it comes under symmetric encryption algorithm. C will be mapping to 4. C4 is available only in 1 option. What about RSA? RSA uses a public-private key pair. So there are 2 keys involved here. RSA uses a public-private key pair for encryption and decryption. It is widely used for secure key exchange and digital signatures. So RSA comes under asymmetric encryption algorithm. D will be mapping to 1. D1 is also available only in 1 option. Option number 2 will be the right answer. So with this we are completing Unit 9 questions.